Hi, this is Miss D, and these are your notes on circuits. This is just going to cover circuits. It's not going to cover any of the calculations associated with Ohm's law. So what is a circuit? A circuit is a pathway for electricity. It has to be a complete loop because the electricity has to get from where it started to where it ended, or it's not a closed circuit. It's an open circuit, and it doesn't work. So the typical things that are included in a circuit are a power source, normally a battery, some wires to carry the electricity, usually some resistors, which decrease the flow of electricity, and we'll talk about those later, and typically some lights, at least in the circuits we use here. So let's look at a typical example of a circuit. In a typical circuit, we have, I want to erase that right there and put that in. Okay, so in a typical circuit, what we have is a battery, a resistor, some wires, and a switch. And this switch can be open or it can be closed. So I've got it drawn open and closed there. So you can see how if it's open, it would disrupt the flow of electricity like that. And if it's closed, then it would go ahead and allow electricity to flow. So those are the symbols. Now let's look at the two types of circuits. You can have a series circuit, which is a single path for electricity, or you can have a parallel circuit, which is multiple paths for electricity. And the paths are typically parallel, like a ladder. So let's look at a series circuit. In a series circuit, I have one pathway for electricity. By the way, that's the symbol for a light bulb. So in a series circuit, my electricity is going to go all the way through there, right? It goes from start to end. Well, what if instead of that, I burnt out this light bulb right here? If that light bulb was burnt out, my electricity wouldn't be able to get past that light bulb. So that entire circuit would be worthless. And in a series circuit, when one bulb burns out, the entire circuit stops working. Here's an example of a series circuit. Old school Christmas tree lights. When one light bulb went out, you had to take all the light bulbs out, plug them all back in one at a time to figure out which light bulb was burnt out. So that's not really practical for most applications in your house. The other type of circuit is a parallel circuit. In a parallel circuit, you have the light bulbs in parallel. So here's what that means. It means I could have my electricity flow like that. And even if this light bulb right here was burned out, it wouldn't matter. But if the light bulb was there, it could also go through that light bulb, right? Or it could go through this light bulb. The only time it would matter is if it was burnt out like in one of the areas leading up to all of them on the sides of the ladder. That is a parallel circuit. Your house is wired in parallel. That way, when you turn on your air conditioner, your oven doesn't turn on the same way. Or when you turn off the lights at night, the air conditioner and your alarm clock don't turn off. Parallel circuits are much more useful for your house. That's it. If you have any questions, come ask me.